Good morning, students. Huh? Good morning, students. Right. Today we are going to discuss discovery of electron. Right. Before starting topic, let me revise yesterday whatever I taught. In yesterday class, we started atomic structure. In that, so first theory was Dalton's atomic theory. According to Dalton's, in the matter there are smallest tiny particles which are uncuttable or undivisible are said to be atoms. So atoms are individual particles. They will exist in all elements and all compounds, and you cannot create and destroy the atoms. And when atoms undergo rearrangement resulted, you will get the different kind of compounds. This is said to be chemical reaction. So this statement is satisfying law of constant proportions and law of conservation of mass and law of multiple proportions. Okay, these are the merits of Dalton's theory. And next, what are the demerits? So means actually Dalton theory, there are no experimental evidences. Without doing experiment, just he gives some postulates, and in that there are few postulates are matching with current experimental evidences. Right. Next, what are the main drawbacks of Dalton's theory? Dalton theory did not explain stability of the atom is one thing, and next, no idea about subatomic particles and no idea about isotopes like in hydrogen, deuterium, tritium are the other kind of isotopes. No idea about isotopes, and did not explain stability and subatomic particles. Okay, these are the main drawbacks of Dalton's theory. Right. Next, after 18th century, Michael Faraday. So he did many experiments in electron field. So when we are passing current through any solution, you can notice there are deposition or discharge of the compounds at corresponding electrodes, like cathode and anode. If you do the electrolysis process, what is electrolysis? Electrolysis is nothing but there will be one cell setup. In that cell setup, you have to take the solution. Which solution you want to do the electrolysis? That solution you have to take, salt solution you have to take it, and in that solution you have to put two electrodes, and these two electrodes you have to connect to external battery. From the external battery, if you pass the current, so definitely there will be discharge. There will be discharge at respective electrodes. At cathode, there will be cathodic reaction. At anode, anodic reaction. So this is what done by Michael Faraday. Then that is what, and he thought he started thinking about matter. So whenever there is electrolysis process, definitely in the matter also there are charged particles. The matter, according to Dalton's, atom is the smallest particle. So after atom, there is no further smallest particle in the matter. That is what given by John Dalton. Michael Faraday proved that, and he got up idea. He got up idea. In the atoms, there are charged particles. So due to this charged particle only, when we are passing current, we are getting discharge. Whenever there are charges, then only they will attract to either cathode or anode. So this is what idea he started, developed, and from that idea, and scientists started knowing subatomic particles in the atom. So this is what the main idea from the electrolysis process only. He got an idea. There are some kind of particles with charge in the atom. That is the reason why. So we are getting what electrolysis at corresponding electrodes like cathode and anode. Then based on the Faraday's suggestions, means from the experimental suggestions, then J.J. Thomson did one experiment. That experiment name is cathode ray experiment. From the cathode ray experiment, J.J. Thomson discovered electron. He discovered electron in the matter. So right here, discovery of electron or cathode ray experiment, according to what J.J. Thomson. J.J. Thomson is the scientist name. Thomson is the man discovered electron in the atom. Now let me give the explanation to get how he discovered electron in the atom from cathode experiment. In the cathode experiment, there will be one glass tube setup. This is what one glass tube. And as you hear, this is one kind of glass tube we have. This glass tube connected with the two electrodes. One side cathode, other side anode. These two are connected to external battery. This is what battery can take it. This is battery, and this is what cathode, and this is what anode. Plus charge is said to be anode, and minus charge is said to be cathode. Now in this we will be having. So here there will be one vacuum pump. This is what one kind of vacuum pump. So what is the role of vacuum pump? So through this pump you can evacuate the gas. Means you can remove the gas. You can create vacuum also. This is what vacuum pump. Vacuum pump. This is what one kind of pump. It will remove the tube. Then you can create vacuum also. Okay, this is what vacuum pump. And here you have to take any one of gas. You can take any H2 or helium, any kind of gas you can take it. This is what gas. And now this gas is having very low pressure, nearly 10 power minus 3, okay, atm atmosphere, or this is equal to 0.001 atm. So you will be having here J.J. Thomson. What he did in this setup means he took one glass tube, and this glass tube is having two electrodes, and these two connected to external battery, and from the battery then you can create potential difference. Okay, you can create potential difference. This negative terminal is said to be cathode, and positive terminal is said to be anode. Right, in between cathode and anode, you will be having the gas with very low pressure. How much pressure with respect to atmosphere will be 0.001 atm pressure, or 10 power minus 3 atm pressure. Very low pressure he maintained inside the gas. Now, and this the battery will give what high voltage. It will give what high voltage. Voltage of current will pass high voltage nearly 10,000 volts. You can create 10,000 volts of that water charge. You can pass from the external battery. Right. Now he started. Now we will start the experiment. We start with what J.J. Thomson started experiment. Now he started passing voltage from the external battery. When we are passing voltage, obviously then there will be current, and now finally here from the cathode you will get what here electrons. Here you get what electrons. These electrons will be traveling through this gas and towards this anode side. Why? Because here from the cathode you are getting negative particle. Always negative particle will be having attraction toward the positive electron. So then these negative particles are moving towards the anode. So this is what he noticed. Then to prove this, here there are negative particles. They are moving towards the anode, and he added some supplement explanation. Right now let me take it here. When we are passing high energetic, this is what electrons. Electrons you are getting from the what cathode. So this beam of electron is said to be cathode ray. So this beam of electron is said to be what cathode ray. So what is a cathode ray? Cathode ray is nothing but what beam of electrons. This is said to be what beam of electron. Beam of electrons. Beam of electron is said to be ray. Ray is nothing but what one kind of light. So here beam of electrons you are getting from the cathode. Cathode is releasing electrons here. So when cathode is releasing electron, definitely it is said to be what cathodic ray. From where we are getting this ray? Ray is one kind of light. Okay, radiation. This radiation is away. So beam of electron, these electrons you are getting from the cathode. That's why it is said to be cathode ray. Now this experiment name is cathode ray experiment. So whatever the ray which is coming from the cathode electrode is said to be cathodic ray. This is a beam of electrons. This cathodic ray is nothing but light beam, there are many electrons. Many electrons. Now, right now, these electrons, when electrons are passing through a gas, here you will be having one kind of gas. Now I will take here H2 gas. Then what will happen here? So here this is what H2 gas. When H2 gas, here when it is passing with a high speed, this is what high speed electron. Why? Because here potential is what 10,000 volts will be maintained. Due to this high potential, here these electrons will move very fastly. Their kinetic energy will be very high. When these electrons are passing toward the anode side, then here gas act like a medium. Here gas, whatever the gas, which is act like a medium. So via this gas, electrons are traveling towards the anode. You need to understand. Now here gas. Now in the gas also there are electrons. Then once there are electrons, then what will be here? H2 plus 2 electrons. 2 electrons. Now here this cathode ray is the what forming positive ions. Positive ions. Then you are getting what? Beam of electron, and these beam of electrons are moving towards the anode. So this is what he explained. Right now let me say one thing. Whenever electrons are passing from this cathode to anode, to get water, to reach from cathode to anode, they need some medium. Medium is here gas. That means what? In the gas also there are some electrons. That's why there will be a passage of electrons from cathode to anode via gas medium. Via gas medium. And now one thing. Here when electrons are passing through medium towards the anode, then they will discharge. Then circuit will be completing. Now this circuit, due to this circuit, you are getting water, current also are getting. And here one thing, this is what the main basic idea. After that, you try to explain here how electrons are getting. Yes, here electrons are what? Invisible. So then how you can notice whether electrons are releasing from the cathode or not? That what you need to prove it. Now same experiment he repeated to explain. Yes, there are some particles. Then same experiment if I have it. This is what experiment. You know that I don't want to take all the things. Just only few things. Whatever required I will take it. This is cathode. And here, now here you will have an anode. This is anode that here. So he made some pores on the anode electrode. Now this is what anode electrode. This is what cathode. Now both are connected to external battery. This is what external battery. Right now that here. So now this is having pore. Now what we are doing here? Electrons are passing toward the anode side. Now back side of this anode, he coated with one kind of fluorescent material. He coated with one kind of fluorescent or phosphorescent or fluorescent type of coated. This is what you will be having one coating. This is what one coating. This coating made up of what? Fluorescent or phosphorescent. Fluorescent, or you can take it as phosphorescent. Here this is what zinc sulfide. You can take it as coating of what? Zinc sulfide. You can take it. So zinc sulfide act as a fluorescent or phosphorescent material. Right now let me explain here. Now electrons are passing from the cathode. Means electrons are releasing from the cathode and they are moving towards the anode side. Now electrons are when they are moving here now on the anode. This is not anode. There will be a pore. Wherever you have the pore, definitely electron will travel and it will go and it will strike backside of this and this anode electrode. There will be a fluorescent. When it is striking on the fluorescent, definitely it will come back and you can see there will be some spark kind of light will be produced. There will be a spark. Okay, spark kind of light will be produced. In this experiment, you cannot see the spark. Why? Because here when electrons are traveling, when electrons are moving toward the anode, so they will go and they will strike and they will absorb on the anode. You can't see that. That means what you can see that here there are some kind of particles are moving from cathode to anode. When this particle is striking on the fluorescent material, then they will be getting spark. So this getting spark is indicating there are some kind of particles which are moving from cathode to anode side. These particles are invisible, but their nature is visible. Yes or no? Here, these particles are what? Invisible, means you can't see the particles. But there, when these particles are what striking, then you are getting what? Spark. Spark you can see the with our naked eye. So getting spark is visible. That means these particles are invisible, but their nature is visible. Their nature is visible. Based on that, so nowadays we will be having tube light. This tube light technology. So in our homes, so there will be a lights, tube lights. Okay. So in the tube light also there will be one kind of white coating. That coating is nothing but water, fluorescent or phosphorescent coating. Okay, this coating. So this coating is like this one. Now in this water, when we are passing current, then so here from the cathode electrons will release and they will go and they will strike on the surface of that coating, white coating. Then resultant you will get the spark. That spark we are getting in the form of lights. Based on this water, cathode ray tube. This kind of mechanism is present in our tube lights. This is what the same thing is what happening in case of what cathode ray experiment. That means what here you can't see the electrons. Same thing water, you can't see the heat. Yes or no? You can't see the heat, but when you touch the hot body, you will experience. Yes or no? You can't see the power. I want to see the power. How will be the power? You can't see the power, but when you touch the wire, then you will feel it. So you will get the current shock. Same way here also, you can't see the flow of electrons. In the current also, in the conductance, you can't see the flow of electrons. But when you touch any electrical wire, when there will be a passage of current, definitely you will get the shock. Getting shock indicates there will be a flow of electron. Same thing here also, you can't see the electrons and their flow in the first diagram. From the first diagram, you can't see the electrons. But when this water backside of anode, when you coat it with the anode, then via this empty space, means here pores are there, means empty space is there, via empty space, they will travel and they will hit backside of this anode. When they are striking on the surface of this coating, definitely they will give the spark. So getting spark means what? It is the nature of one kind of particle. When, for example, here, when you let us here, there are two rocks. So when one rock is striking on the other surface of rock, then what you will see that you get spark, no? Yes or no? That means any body, when it is striking with high speed on surface of other metallic thing, or one metal with other metal, or one solid with other solid, definitely there will be a getting of spark. There will be a getting of spark. That means what here? This is particle nature. Now here what is the nature of electron here? Is it particle nature or light nature? Particle nature. When this high speed particle is striking on the surface of this fluorescent material, you are getting spark. That means here is the electrons are the one kind of particles, and this beam of particles is said to be cathode ray. Beam of many small particles is said to be cathode ray. Like that, from the cathode you are getting many electrons, or that what depends on what voltage you will get what per second. How many electrons you are getting, you can calculate. So it is not required. Right, these electrons are moving towards the anode. So there will be a discharge on the anode. This is what from the first experiment, and you have to prove that yes, electrons are moving from the cathode to anode by taking this anode, this fluorescent coating on the backside of anode, then you can prove it. So then same way here, electrons are moving, then they will go and strike they will hit on the surface of fluorescent, then you get the spark here also. Same way here also, electrons will move and they will strike, means they will hit on the surface of this one, then you will get the spark. Like that you will get. Like that in tube light, there are a number of electrons continuously, they will go and they will strike on the surface of tube light fluorescent material. The resultant, once you switch off, then what you are doing, you are stopping the flow of electrons. No? When we are switching off, then there is no power. There is no power means you are stopped this flow of electrons. Once we stop the flow of electron, then you can't get it this type of mechanism. So then there is no glowing of bulb. There is no glowing of tube lights. That is what the mechanism. So you can explain. That means then from this what you can say that in every matter, electrons are the charged particles. They are negative. Why? Because these particles are moving positive electrode side. When they are moving positive electrode side, definitely they should have negative charge. This is what the cathode ray experiment. Right, now let me explain once again here. In the cathode ray experiment, from that you can explain in every matter there are negative kind of particles. Their name is what actually J.J. Thomson did not give the name of electron. Name of electron given by Stoney. Okay. So Stone is the scientist's name. So he gave the name of electron. And J.J. Thomson discovered and he explained the properties of that word electron. He explained properties of electrons and he discovered, so there are negative charge particles are present in the matter. In every matter there are negative charge particles are present. These particles name given by the Stone is the scientist's name, and negative charge particles discovered from the cathode experiment by J.J. Thomson. Right now with the J.J. Thomson there will be a cathode ray tube, and in that water there two electrodes, and these two connected to high voltage battery. And now here there will be evacuated or vacuum pump will be arranged. Due to this vacuum pump, you can remove the gas and you can maintain required pressure inside the tube. This is what the pressure. How much pressure you have to maintain? 10 power minus 3. So compared to atmospheric pressure, it will be very very low pressure. So at this pressure, now we are passing what? Now we started passing current from the battery. How much? We need to pass the 10,000 electron volts, means high voltage you have to pass it. When we are passing high voltage, definitely then so here electrons will move with high speed, why? Because potential difference is very high. When electrons are moving through gas, definitely gas will get what? Ionized. This electron will go and it will combine with electrons of this matter. Then it will give what? Electrons. So resultant you are getting what? Beam of electrons. These electrons, due to negative charge, whenever particle is negative, definitely obviously it has to go positive side. Okay. So right, now this is what positive side. These are the observations. Prove it. Yes, there are particles, they are moving towards the anode. How you can prove it? By taking this word fluorescent coating on the back side of anode. You can take it. Now here, now you started passing that water, passing this voltage, then we have started current, then there will be a flow of electron, and this flow of electrons will travel via this force of anode, then they will go and they will spike on the surface of fluorescent material. Then you can see the one kind of sparkling light. This indicates there are some negative particles are coming from the cathode. These particles are said to be cathode ray particle or cathode ray. These particles are moving toward the anode, and these are invisible. These particles are invisible, but their nature is visible. Their nature is visible. So this is what the technology we are using in the tube lights. In the tube lights. So now this is what yes, there will be some kind of particles are coming and they are striking on the fluorescent or phosphorescent material like zinc sulfide. Then only you are getting the spark. This is what he proved. That means some kind of particles will be there in the every matter. Their nature is negative charge. Their nature is negative charge. From this experiment he gave it. Next, they are having particle nature. Also he proved that. How he proved that? You can take here same diagram here. Let me explain here one thing. This is what vacuum pump, same water, same discharge tube we have. You can take here. This is what connected to external battery. This is minus plus. This is here cathode and anode addition. Now here I will take here. This is what one paddle. I will arrange here one paddle, one kind of paddle. So what is the paddle here? This is what paddle. This is what paddle. Here I arrange what one paddle, rotating paddle. Now here what will happen here? If it is ray, these electrons are behaves like a wave nature. So actually nature of electron is what? Wave nature as well as particle nature. So electron is having dual nature, particle nature as well as wave nature. Right now from this diagram, so it is not given in the NCERT, but electron nature is what particle nature you can explain from this experiment, and wave nature also. It's a dual nature. Finally, nature of electron is dual. So that is what we will conclude end of this topic. How electron is behave like wave and particle. Right now here what I am doing here, same experiment I repeat it, and in between what cathode and anode. So I arrange one paddle, okay, rotating paddle like fan. So it will be there. Now what? Now I started passing what electrons. So when I am passing electron, if it is ray, you have to get shadow of this paddle. No? Yes or no? If there is a ray, definitely you have to get the shadow. No? Yes. Now I am getting light. So this is what the light. Light is wave nature. Yes or no? I am getting wave nature light. Then I am getting here. You can see that. You can notice my shadow. Back side of me, you can see the shadow. That means what? This is what ray. Yes or no? Same thing here also. When electron is what? Wave nature. Definitely you will get what? Shadow of this pattern. Back side you will get somewhere. This is what shadow. Like this shadow you will get it. This is shadow you will get it. This is what it indicating what from this observation what you can conclude. Yes, this is what ray. That's why we are calling cathode ray. Yes sir. No, when we are passing ray means the wave nature. When we are passing ray, definitely we have to get shadow. We have to get it. When we keep any body or object in the path of this ray, definitely we have to get this shadow. This proves that there will be a wave nature of electron, or electrons are not one kind of rays. This is what you can do. Next, when electrons are moving towards the anode with a high speed, then what you can write here? With high speed, definitely they will go and they will strike on the surface of paddle. Yes or no? When they are striking, definitely this paddle will rotate. There will be rotation is taking place. Rotation is taking place. So here there is no connection. There is no connection to this paddle. But here when we are passing this electron beam, so then if it is particle nature, definitely. So whenever here one particle is striking on the other particle, definitely it will displace no. Yes or no? So this is what happening. This indicates what particle nature of the electron. So now here when electrons they are striking with high speed on the surface of this paddle, obviously they will rotate. Paddle will rotate. So this word getting rotation indicates this electron nature is particle nature. Electron nature is particle nature. So this is what from the cathode ray experiment of the from the J.J. Thomson. Right, now let me conclude this water experiment and its from the experiment observations. Here discovery of electron or cathode ray experiment which was done by J.J. Thomson. Right, now in this according to Thomson experiment you will be having one set of in this glass tube you will be having two electrodes and these two connected to high voltage battery. Nearly 10,000 volts we are passing from this battery, and now here pressure will be very low pressure, that is 10 power minus 3 atm pressure. Now I started passing this watt potential through the electrodes. Then when I pass high voltage of potential, then there will be a flow of electrons from the cathode. So then now you are getting what beam of electrons towards the anode via this gas. Here gas you can take it. Here I have gas H2. You can take O2 or N2 helium or any kind of gaseous state of matter you can take it. When we take gaseous state of matter means in any kind of matter definitely there are negative charge particles. So that's why you are getting what there will be getting electrons. There will be getting electrons from the matter. That's why you are getting beam of electron, and this beam of electron is moving towards the anode side. So now these electrons will go and strike on the surface of anode, then they will get discharged. This is what the normal experiment. Yes, there are some kind of particles or rays are coming from the cathode. These rays are said to be cathode ray. This is what you can prove by taking one fluorescent material by coating on the backside of this anode. Then when if it is particle nature or something is coming, when it is striking on the surface, definitely you can see that one kind of spark. This getting spark indicates here there are one kind of rays or particles are coming, and these particles are invisible but their nature is visible. So getting spark is visible. That what you can prove that. He proved that yes, there are some invisible kind of particles or rays are coming from the cathode. Then when they are striking on the surface only we are getting the spark. The electrons are there and these particles charge is negative, that's why they are moving anode side, and they are invisible but their nature is visible. This is what he concluded from this. Up to this we have NCRT. Next, one more extra information. In the path of electron, if you arrange one paddle, then when electrons are moving with high speed, definitely they will go and they will strike on the surface of this paddle. Then paddle will get starting rotation. Then once you get start rotation, it indicates what there will be a particle nature. When one particle is striking on the surface of other particle, definitely you need to get some displacement. So due to this displacement, then obviously paddle will rotate. This is one thing. And next, this indicates what particle nature of electron. Next, one more thing, you can explain wave nature of electron. How will be the wave? If wave is like means electron is a one kind of ray. One kind of ray means one kind of light. Definitely, when we are passing light on means via any object, definitely you have to get its shadow. Getting its shadow indicates there will be a light nature or wave nature. Okay, that is what ray. We are calling here cathode ray or cathode light or cathode means a beam of electrons. We can call it with any name. So finally, what you have to conclude from these experiments? Nature of electron is wave nature as well as particle nature. It's a dual nature. This is what you have to consider. There are electrons. There are electrons and their charge will be negative. That's why they are moving toward the positive anode side. And next, electrons are invisible, but their nature is visible. When they are striking on the surface of material, definitely you will experience, yes, there are invisible kind of particles are there in the atom. That what we can conclude. Then from the J.J. Thomson finally concluded that so there are negative particles are present in every matter. Their charge will be negative. Then so in the every matter you have the negative particle, and that what he gave J.J. Thomson. Later Stoney is the scientist name, and he gave the name of electron. Okay, name of electron given by the Stoney, and nature and properties of electron will be discovered by the J.J. Thomson. J.J. Thomson. Next, charge on the electron. Charge on the electron discovered by the Mulliken. Okay, there are three scientist names you need to remember here. One is what electron name. Electron name is given by what? Stoney. And next, electron properties and behavior. Properties of electron given by what? J.J. Thomson. And next, charge of electron will be discovered by Mulliken. So these are the known countries here. Name given by Stoney, and properties and behavior of electron discovered by the J.J. Thomson, and charge of electron will be discovered by Mulliken from the Electron experiment. Later we will discuss Electron experiment. Right now, we can conclude from the J.J. Thomson experiment or cathode experiment or discovery of electron. So this is what discovery of electron. Right. The next calculation of finding what charge of electron. Who discovered charge of electron? Who discovered charge of electrons? Mulliken, no? Right, Mulliken from Electron experiment. No one will ask in board point of view also, no one will ask experiments. Just from the experiment, whatever the results, you need to analyze. Okay? Go and see the NCERT textbook. In that you will find the diagrams. Okay? I don't want to go through diagram. So drawing diagram will take time. Okay? So you can see that NCERT textbook. In that you will find the finding charge of electron from the Electron experiment by Mulliken scientist. So in the Electron experiment, okay, so there will be X-ray setup, and he arranged two electrodes, and anode and down cathode will be there, and he sprayed some oils from the atomizer. From the atomizer, he sprayed the oil, and these oils will fall on the anode electrode, and after that, then this oil drop is falling down on the cathode side. Then you have to pass X-rays. When we pass X-rays, definitely these oil drops will get what? Charging. Charging means then there will be a formation of charge. This oil drop charge, that is what Q will be equal to n number of that what electrons into 1 electron charge. It's very, very important. So this is what charge of drop. Okay, droplet, oil droplet. Charge of oil droplet. This point is very, very important. In droplet point. This is what point only one point you have to remember. So here charge of oil drop, total charge of oil drop will be equal to n into E value. So here n will be always some integer number 1, 2, 3, 4, 5 like that you have to get it, not fraction. Why? Because number of electrons never be fractional. So always you have to get either 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, 10, 20, 50, 60, 100, 200, 500, 1000. So number of electrons must be some integer number we have to get, not fraction. And then here what? 1 electron. This is what 1 electron charge. So always 1 electron charge. So what is the electron charge here? E will be equals to what? Q by N. Then this is what experimentally value will be given, which is equal to 1.6 into 10 power minus 19 coulombs. This is what one electron charge. One electron charge will be given. Mathematical value will be equal to 1.6 into 10 power minus 19 coulombs. This is what SI unit. Coulomb is the unit of electrons, charge of electron in SI units. If you take it in CGS units, 4.8 into 10 power minus 10 ESU, electrostatic units. It's very, very important. Charge of electron in SI units is the coulomb, 1.6 into 10 power minus 19. And in CGS units, 4.8 into 10 power minus 10 electrostatic units. This is what ESU. E means electro, S means static, and units. So ESU is the CGS unit, and 1.6 into 10 power minus 19 coulombs is the SI unit. So please just you have to remember this formula. Okay, in competitive point of view, no one will ask a diagram how that what Aldrop experiment will take place. No one will ask. Just you need to understand. For Aldrop, from that he discovered charge of electron, and this is what charge of Aldrop will be equals to what, one electron charge into number of electrons present in the Aldrop. Yes or no? So total charge of Aldrop will be equal to what, one electron charge into number of electrons present in the Aldrop. Now one electron charge will be equals to what, total charge by number of electrons. Then you will get charge of one electron. Then he discovered charge of electron value will be equal to 1.6 to 10 power minus 19 coulombs. So this L value will be always some integer number, not fraction. It's very, very important. Sometimes they used to ask logically also. Here, for example, just let me ask one numerical point of view. Here, one numerical, how they can ask. Right now here, let me have one ion drop will be there. Now this is what one ion drop. In this Q will be given, which is equals to 10 into 10 power minus 19. 10 into 10 power minus 19. So in this water, there are what L value will be equals to 5 will be given. Then what is the charge of electron? What is the charge of electron from this? Right. So now here charge of electron will be equals to Q by L, which equals to what you can get along. So 10 into 10 power minus 19 by 5. Then value will be equals to 2 into 10 power minus 19 coulombs. This is what according to question, charge of electron value will be equal to 2 into 10 power minus 19. So like that, don't think it here. So one option will be given here in this question. One option will be given 1.6 into 10 power minus 19. First option in coulombs. Second option will be given 2 into 10 power minus 19 coulombs. Third option is given 5 into 10 power minus 19 coulombs. And fourth option will be given, so 10 into 10 power minus 19. Now answer is what? What is the charge of one electron according to this question? What is the correct? 2 into 10 power minus 19 is the correct answer. Not 1.6 into 10 power minus 19. Are you getting or not? Right. When data is given, when you know the charge of the total oil droplet and number of electrons in them, then this is what the charge. Okay. So the, like this numerical application point of view, one electron charge will be equal to 2 into 10 power minus 19 is the value, not this. Okay, like a numerical point of view, you can expect the questions. This is what the maximum, this is what application of Mulliken Aldrop experiment. Okay, right. Next, E by M ratio means getting mass of electrons. How we calculate getting mass of electrons? Right now, electron is what right, this is what Aldrop experiment. Right, today I will continue, tomorrow I will continue from this. Right, let me revise once. Today, in the today's session, we had discussion how electrons will be discovered in the matter by cathode experiment from the J.J. Thomson observations. Okay, and here finally, in every matter, what you can conclude, in every matter there are negative charge particles. Their name is what? Electron, and they will always move from towards the anode. You can't see the electrons, but you can experience their nature. This is what you have to conclude. Right. Next, electron charge will be discovered by the Mulliken. Name will be given by the story. Electron charge will be discovered by the Mulliken from the Aldrop experiment. from the oil drop experiment. In the oil drop experiment, total charge of oil drop Q is the charge, will be equal to number of electrons into 1 electron charge. Here L will be, you have to take number of electrons, you have to take integer number, not fractional. It's very important. In any problem, L value is getting fraction means that is wrong. That is wrong. Why? Because number of electrons never be fractional. That what based on this formula, right? From the Mulliken experiment, he got 1 electron charge value will be equal to 1.6 into 10 power minus 19 coulombs. Electron charge will be equal to Q by N. We have taken. Then this is what the value of charge in coulombs, SI unit. If they ask in CGS unit, what is the charge of electron? 4.8 into 10 power minus 19 ESU, electrostatic units. It's very important. Most of the students, they know the electron charge in coulombs only, not in ESU. ESU also very important. Later in topics, we will apply this electron charge also. It is CGS unit. In CGS, 4.8 into 10 power minus 10 ESU. This is what I taught. And when numerical is given based on this formula, based on this formula, you have to get the 1 electron charge. Here in this question, so total, here the charge of 1 droplet will be given, that is equal to 10 to 10 power minus 19. And in that droplet, there are 5 electrons will be there. Now, if I ask question, what is the charge of electron? Now if I ask then, total charge by number of electron, we will get 1 into 10 power minus 19 coulombs. Now when option is given, like you have to take 2 into 10 power minus 19. We should not take 1.6 into 10 power minus 19. So based on the question, we will get the charge of electron. When droplet charge is not given, then according to Mulliken only, you have to take the 1 electron charge equal to this much directly. Okay, this is what the reference for the experiment. Okay, this is what the reference. If I do the experiment, then so I will get different charge. But according to reference, when this was the droplet charge is not given, for 1 electron we are having this is the charge in coulombs, this is the charge in ESU. Okay, right. Tomorrow I will continue discovery of other subatomic particles and finding mass of electron and behavior of electron, how it will be when we are passing through electric field and magnetic field. And from that, so how we can discover the molar means mass of electron. Okay, this is what tomorrow I will continue. Okay, thank you.